Okay, today's tutorial is a little bit shorter because it's based around some of the concepts that you've already learned. I'm just showing a different technique. So previous to this we talked about controlling a player sprite, so if you've done those tutorials you know about controlling a player through a D-pad on a game controller. What this tutorial endeavours to do is just to show you the little extra bits you need to do to allow you to use keyboard control within the game. It's been done in that sequence because initially it's much more accessible for students to work with a mouse, because every computer student will have a mouse of some sort. We included the game controller first of all because I'd like to encourage you to make use of other controls other than just the keyboard. But now we've gone through the concepts, we can actually go through and create, just by a little bit of modification, a version that actually allows us to control the player by a keyboard. So what we have here is effectively a trimmed down version of the example that I gave you for a D-pad. What I've still got is I've still got a clicked event, which you can see that we created. We'll look at that later on. First of all, we're going to look at how we control the sprite using the arrow keys on the keyboard. So first of all, if we look into our code, what we have here is pretty much what we had before. I've removed all the game controller bits out of the if statements. I'm going to very quickly show you how you can now modify this so that it allows you to use keys instead of the gamepad. So, as we've discussed before, direction is basically indicating the direction we want to move our sprite at each screen update. And in this example we're moving it at 1 pixel, so x in -1 is moving it to the left, x plus 1 is moving it to the right, y minus 1 is moving it up, my y plus 1 is moving it down. So all we need to do really is to make this work and to make it actually control the sprite on screen is to give us the ability to read the keyboard. So keyboard is the class, and it shouldn't come as any surprise by now that getState is the method that we're going to use. Now alongside that we have two options now of is key down and is key up. Obviously what we're actually reading here is a boolean, it's going to be true or false. So if we want it to check whether or not the user is actually holding down a key, we can simply just use is key down. So type in is key down and then an open bracket. The next thing it asks for is actually what key you want to press. Built into XNA is an enumerated data type or a class that basically allows you to specify the key by its letter or its name. So for in this example I'm going to use the arrow keys. I know a lot of game players like the A, W, D, S keys and things like that for their gameplay, so you obviously can modify this as you like. So realistically you just use the keys object, and then when you click the dot on your keyboard it will allow you to then choose what you're actually going to use as your key. In this case, because we're using X and it's -1, so we're moving to the left, if we just type L, E, it pulls up left, and at that point that's indicating it's the left arrow key. So last thing is obviously to complete the bracket on the method, and at that point what will happen is when this state is read, if the left key has been pressed down it will return true. So if it returns true then it will execute that line of code. And it's just a matter of replication to actually get the other keys to work. It's probably one of the easier things to do in XNA. I'll just duplicate it into each if statement first. Okay, and then we literally just modify which key it is. So if we want to go right, we use the right arrow key. We go up, direction -1 because the top of the screen 0, 0, and down. Okay, and at that point what we've done is we've now created a situation where our player can move around in any way that they want. Now if you remember from the previous example we used the controlling the animation as an example of how we could respond to a key. It's not probably something you'll want to do in your game, but it at least gives you a visual clue of what's going on. So spaced clicked is basically the same method as we had before for button presses that we used on the game controller. The only thing is that because we're working with keyboard get state, up until now we've been talking about button pressed or released. Now we need to deal with Boolean values. Now I've already modified this code because it's effectively the same thing, but we'll look at it anyway. Alright, so here we are, here's our space clicked method. Alright, and as you can see, it relies on a variable called space to record the previous state of the keyboard. So we need to put that one in first of all. Again, this time it's still private, but we also need to make sure that we're actually using the right data type, so it's Boolean. Okay, and call it space. And obviously we need to give it an initial value which is false, which means the key wasn't pressed previously. And at that point that will now keep track of that. So, obviously this is the update method, so it's being checked every screen update, and a call's being made to space clicked. So if we look in here, it says if space equals false, which it will do in its initial state because that's what we set it as a default, and the keyboard space key is pressed down, which will return true. Alright, so if previously it wasn't pressed down and now it is, then what we can do is we can return true, which means that we've just transitioned from an unpressed spacebar to a pressed spacebar. And obviously we need to update the space to deal with that. Okay, so at that point what's going to happen now is that's going to be called, in this case it will return true, and in this case it will return false. So if there's a transition, true; if there's no transition, it's false. And given that what we're doing here is we're calling next frame, so we're calling the next frame of the animation, that means that the sprite will animate one frame further on. So if we press play, we have our normal bit of code, the examples there. Sprite's in the top left hand corner. Pressing the right arrow key moves us to the right, pressing the down arrow key moves us down. Okay, left, right, up and down. If you combine the keys it still works, there's no trick to it to deal with multiple key presses. Fortunately we live in a world where things are a lot simpler than it used to be. At one point you could only respond to one key press at a time. Pressing the space bar will allow it to advance one frame of animation at a time. If you hold the space bar down, it doesn't animate. Right, it's a transition. Okay, so a single press only. If you wanted it to repeat, then obviously you would have to put in some sort of delay or something to reset the keyboard state occasionally, so allow it to animate at a particular rate. Okay, and when we talk in the future about a delay class, you could possibly look at that as an option. Okay, so it's quite a simple thing. It allows you to just give you a little bit of keyboard control. What I will just add as a little extra here, just so you can think about this, there's nothing wrong with entering two keyboard and gamepad control instructions. Okay, it does take a little bit of common sense to do it, but there's nothing wrong with duplicating these if statements and having another set that says if they've pressed it on the game controller, this also sets the direction. Now you shouldn't concern yourself too much with that if you're using static values like this, because the reality is if the user for some reason stupidly decided they wanted to hold down the left arrow key on the keyboard and the D-pad at the same time, the direction X would still be set to -1, so it wouldn't speed the thing up. Alright, what you have to be careful with is situations where these things add values, in which case it could be possible for somebody to access both the game controller and the keyboard and actually double the amount of movement because they're pressing both at the same time. So just take that as a consideration as well. Okay, that's pretty much it for this tutorial. What we'll be looking at next is we'll look at some idea of how we deal with collision detection, because at the moment all we can do is move our sprites around on the screen and put some text on the screen.